Hi there and welcome to today's class. For today's class, we're looking at the solution to experiment M2, which is simply the obstructed simple pendulum experiment. The aim of this experiment is to determine the relationship between the periodic time capital T and the length y of the path of a simple pendulum bulb allowed to oscillate. Alright, so we have our apparatus here and all of this. So for this video, I'll just go straight to the table values and how to fill up the tables and what have you. Alright, so let's go straight to tabular readings. Alright, so we have this for a tabular reading. So you can see, repeat the experiment for y equal to 30, 35, 35, 30, 25, 15, and 10 tm. Result. The time for 20 oscillation, you have T1 as 40.25 seconds, T2 as 39.94 seconds, your mean T, this. Alright, period TL, T subscript L as 2.00 seconds. Now, for this table, usually, the value of this T1, the value of this T2 and will be given. The mean T is gotten by doing T1 plus T2 all over 2. That gives you this value. So simply 40.25 plus 39.94, your answer divided by 2, you should have 40.10 seconds. The period TL will also be given in the lab. Now usually for this table here, you'll be asked to find the value of you'd have to do the practical to get the value of T1, T2, T1, T2 at y equal to 40, 35, 30, 25, 20, 15, and 10. So for this, you just have to fill up T1 and then do a second time count for 20 oscillation and you get this. So this is where you usually stop. All right. And you have to do the mean T and the others by yourself. So I'll show you how to get the mean T here and then we can proceed. So to get this value here, the value in this column, that's this column here, your mean T value. Usually to get your mean T value, would have that the mean T, your mean T is usually equal to T1 plus T2 divided by 2. So divide this by, so divide this by 2 to get the value of your mean T. Divided by 2. Alright, so let's start with this first one here, this one here. To get this first value here, this one, 25.20, what you do is as simple as this first one here, T1, plus this one here. So that becomes 25.03. So that's equal to 25.03 plus this value here, 25.00. So that's equal to 25.00 divided by 2 becomes divided by 2. So divide this by 2, and if you do this, your value will be equal to 25.02. So this is how we fill up this column. Alright, do the same thing for all of this and you fill up this column. So that means the next one becomes, just do this plus this divided by 2, you have this one here. Alright, so just follow the same process to fill up the mean column like all of this. So that means for this one, you have this one here, 15.74 plus 15.89 divided by 2, and you have this value. That's the simple idea there. Just do T1 plus T2 divided by 2, you have your mean T. Alright, having said that, let's look at the next column. My next column is this column here, where you have period. This one here, where you have period ty. This column here, this is my next column. So how do you fill up this column? Let's assume you've not filled it yet. How do you fill up this column? Your ty column, your period ty column will be equal to the mean t. You have mean t divided by number of oscillations. So divided by number of oscillations. If you look at this point, you can see that it's 20 oscillations. Also check your question, right? Let's go back to our question there. Alright, so coming back to here, you can see by timing 20 complete oscillation. So it's 20. So we'll divide it by the number of oscillations, which is 20. So divide this by 20 becomes all over 20. And that's equal to, put in values, my mean t for the first one, which is this, I have 25.02 to 25.02. Divide this by 20 and I'll have 1.25 as my answer. That's how I got this value here. Alright, do the same thing here. So here will be 23.64 divided by 20 and that will be equal to 1.18. That's how we get this value here. So that's how you get the values in this column. It's simply this one here divided by 20. Divide each of this by 20 and you have these values here. That's it. Alright. Okay, let's proceed. Let's proceed. So if you've not done yours yet, just do that simple maths. Divide all of this one here by 20 and you get all of this here. So that's the task there. Alright, so if you're done with that, our next column is now this one here, ty squared. And of course, that's quite simple. Ty squared is simply your ty column, just square it. I think that's easy enough. That's equal to, the first thing I have here is this one here, that's 1.25. I have 1.25. I'm going to square this. Square this, you have about 1.56 as your answer. That's how I got this one here. Same thing for the second one here. I have 1.18. So square that value. You have this one here. 1.39. 1.39. So square this one here. Square this one here. 1.10. 1.10 square. And you have 1.21. So 1.21. So that's basically how you get that value, right? So square each of these ones here and you get this value, this value, this value, and then this value. So that's how you can fill this for your own practical manual. All right, so what's the last one there? The last column, which is this column here, is simply t squared. So you can see that they said t squared is equal to, look at what is here, tl squared, that's tl squared minus ty squared. So that's equal to, if you look at this, the value of TL is what you have here. Look at this point here. And it's a constant, which is 2. Alright, so it's 2. So that means this value here, TL is always 2 squared, which is actually equal to 4. So it's always 4 minus. Let's look at the first TY. My TY squared is this one here, which is 1.56. So 1.56 minus 1.56 and that will be equal to 2.44. That's how I get this answer here. For the second one, it becomes the same thing. So just simply TL is 2, is a constant. So it will always be 2 squared, which is 4. So it will always be 4 minus whatever you have here. In this case, 1.39. 4 minus 1.39 gives you 2.61. Okay, that's how I got this value. Okay, next up, if I still proceed with that, let's try one more. The next one becomes 4 minus 4 is just simply this one here, 2 squared, don't forget. Okay, 4 minus, the next one should be this one here, 1.21. If I subtract that, I'll have about 2.79 as my answer, which is this. So basically, you can fill this one up by doing 4 minus all the terms here. That's it. And you have that answer. So take them one by one and you have that. So this is how you fill up this table. Alright. So my next task now is to fill up the data analysis. The first one says plot a graph of t squared versus y. Alright, so from the table, let me plot my own graph. Alright, so here's my graph of t squared versus y. Back to this. For a graph of t squared versus y, don't forget that t squared would be on the vertical axis. Alright, this would be on the vertical axis. While y, or the values of y, will be plotted on the horizontal axis. Alright, that's it. Now, since you're asked to plot a graph, don't forget every graph must have two things there, which includes your title and your scale. So what would be my title here? The title of the graph, title, will simply be graph of, so it's just pick up this one here, that's all. That forms your title. That's graph of, my title becomes graph of t squared versus y. That's it. If you want to, you could still put on the units there. That's t squared in second squared if you want to, and y in centimeter. That's here. So you can still add this if you want to. So basically, this is how you get the title of the graph. My next task is to get the scale of the graph. So how do I plot scale of the graph? So going for this, how do you scale this? Well, if I look at this, for my scale, if I look at this, the idea is this. From this point, so this is my plotted graph. You just plot your graph, but let me show you how you get scale. So my scale will be this. From this point to this point is called 1 unit. And 1 unit is equal to, if I look at the t-square axis, that's this, t-square axis, we can see that from here to here, 1 unit is about 0.5. So I'll say let 1 unit, so to be scale use, every graph must have title and scale use, please. Scale use, I would say let 1 unit represent or be equal to whichever one. So represent 1 unit was 0.5, 0.5 in second squared. Go back to your graph. So this is 0.5. From here to here is 0.5, which is your 1 unit. And your unit here is in second squared on the t-square axis. So second squared on the t-squared axis. Let me move this. On the t-squared axis. So proceeding, and let's see our y-axis. So go to the y-axis here. You can see that for y-axis, from here, from the origin to this point, which is 1 unit, represents 5. 5, your unit here is in cm. So 5, which is this, your unit here is in cm. So say let 1 unit represent 5 cm on the y-axis. All right. Let 1 unit, and let 1 unit okay, move this, represent 5 cm on the y axis. All right, so this is how you get your title and your scale. So for this, please, using this idea, write out the title and the scale for your own graph. For me, I'm taking this one off so I can proceed. Okay, let me leave it there for the meantime. All right, so I've gotten my graph and whatever thing there. The second one there, let me look at the next question here. So I've gotten my, what's it called? Plot a graph. I've plotted my graph. The second one here says the slope of the graph S is equal to. Now, luckily, this software gives me my slope. My slope is what I can see here. This one attached to X. That's about that's minus 0.04 approximately as my slope. So you can just get your slope from your graph. Mine is about minus 0.04 as my slope. But then the slope should have an SI unit. So usually my slope should be slope. Let me calculate this a bit. It should be this way. Slope is equal to change in this one here. That's t squared all over change in this value here, which is y. And that should be equal to t squared 2 minus t squared 1 all over, so divided by y2 minus y1. So of course, again, you look for that point where, let's see if you can get points. Look for the point where they meet. Let's see, can we get point like that here? Let's see. Okay, you can take this point here. This one's a good one. So you can take this point here. Don't forget, we said, go back to this. When it comes to taking your points for your slope, look for, if I have a horizontal line like this, if I have a vertical line like this, and then you have the line running this way. All right. So look for this point, a point like this where they all meet, something like this. All right. Look at a point like this, where 3 lines like this meet. That's how to pick up your point for slope. So going back going back to my diagram, I have the, let's see if I can find points like that. Let's see. We could manage this point. For this one, of course, the software has done the work for me. So, but let me just show you how we get this. We could take this point here. This one is good. We could take here. This is a good point. This one is good. Where else can we pick? Let's see. Okay, let's manage this one. Let's look at this point here. Let's see if we can manage this. But for yours, please make sure they're accurate. I'm just trying to show you how we can do this. From here, trace this downwards like this, like this, like excuse me. Trace this like this, like this, like this, and then this. Just trace it this way. Please make sure your lines are straight. Use a meter rule. All right. After tracing this, what next? This point here, trace this to this axis. Also trace this to this axis. Okay. Trace this one down and trace here down. All right. So here becomes the value of um, T2 squared. All right. This one here. Okay. Let me bring that here instead. All right. So trace this value. Here becomes the value of T2 squared. Here becomes the value of T1 squared. Here becomes the value of Y2, and here becomes the value of Y1. All right. So trace this now. What do you have here? If I trace this, let me get this. Let me get an off first. Okay. So here becomes the value of Y1. So if I should get this T2 squared, T2 squared, this one here, we can see this as 3. That becomes 3 minus T1 squared, which is here, is 0.5, 0.5 all over Y2 minus Y1. Y2, 5, 10, 15, 20, 25. So here should be 25. That's 25 minus Y1, which is here, is about 90. So it becomes minus 90. All right, let's get this math done. 3 minus 0.5 is about 2.5 all over 25 minus 90. Let me punch that. That's about minus 65. So minus 65. So 2.5 divided by minus 65. That's about minus 0.038. I have this. So you can see that this even gives us minus 0.0379, which is still correct. So you can see that it's actually correct. Now the thing is, how do I get my units for the, so if I approximate this to 2 decimal places, that's about minus to 2 dp, that's about minus 0.04 as I got. You can see that exactly. So it was actually correct. So that means the software was actually correct. So back to this, let's get the unit of my slope. Now for my slope, now observe that I'm having change in t squared. T squared is measured in second squared all over y is in cm. So I have this. So you can see that this is equal to second squared per cm. This becomes the SI unit of my slope. So my slope becomes second squared per cm. So this second squared per cm. We have this. So yeah, so usually the slope do have an SI unit. So for this is second squared per cm. Next up, you asked to find the intercept on the t squared axis. So back to my graph. Again, this gives us the value, the software gives us the value of the intercept here as 3.94 approximately, which you can see here is close to 4, somewhere around here. It's close to 4. Let me see if I can, you can zoom in a bit. Okay, so you can see this. So you can see this is my intercept on this axis, this part here, and they give us the value as 3.94 from the software. So I'll just come here and put it as 3.94. So the value is about 3.94. Since it's on the t squared axis, it will take the value or the SI unit of t squared, which should be what there? Second squared. So I have this. Alright, so we now have this as the slope of the graph and the intercept. We've gotten this. So you please get your slope and your graph using this same idea. All right, next up, let's move to the questions. The questions one says, derive the relationship between t squared and y and relate s and c with the physical constants of the setup. How do we get the relationship between t squared and y? The idea will be very simple. Okay, so let me take off this scale and title. Hopefully you've copied this already. So let me take off the scale and title and see what we can get. All right. So we asked to find the what's it called? The relationship between t squared and y using s and c. Now, if you recall the equation of a straight line, for a straight line, recall that we have that. Let's say I have something like this, where this is y, this is x, and I have this something like this. Okay, let me make this bigger. So here's what you should note. If I have a graph like this, okay, where this is y and this is x, and such that the graph goes this way, like this, okay, and I have my slope. Let's say the slope is equal to m, and let's say it cuts the y-axis here at, let's say, c. From the idea of straight line equation, we say that y will be equal to what there? Mx plus c. This is the equation of a straight line. So how does this help us get the relationship between t squared? Now, in our graph here, note that you don't have y here. What you have here is actually t squared. So y here should either be what? T squared. Also, you don't have x. What you have here is y in cm. So instead, we now have y here in cm. The slope, as we found, if you check, we found our slope, which is this one here, to be what there? Minus 0.04, minus 0.0, okay, let me write this better, minus 0.04, and also we found the intercept, that's c, as being what's there? 3.94. So if you are to recreate this equation in this form, what will it be? It means that the y, which is in this case t squared, will be equal to m, the slope. The slope is minus 0.04 into x-axis. For this, we have y lying in the x-axis. So it becomes y plus c. C is the intercept, which is this 3.94. So I'm having 3.94. This becomes the relationship between t squared and y, and the relationship between s and c here, right? Where s is the slope, minus 0.04, and c is 3.94. If you want to, you can still rewrite this as saying that t squared is equal to, take the positive first. So positive first becomes 3.94 minus negative 0.04y. This is much more proper. Now, if you leave it as t squared equal to minus 0.04y plus 3.94, it's correct. But then when it comes to mathematical idea, it's better you take the positive one first, which is 3.94, before the negative one. And that's why we have this one here. So hence, I can say that the relationship is that t squared, so you have that t squared is equal to 3.94 minus 0.04y, 0.04y. So I have this. So this is still correct. If you want to use the negative first, that's still fine. We can confirm this. If this equation is correct, we can confirm it using our table. So if you get back to our table, let's get back to our table. All right, so back here, just to verify, we said the equation is t squared is equal to 3.94 minus 0.04y. So let's confirm that. Let's use the first one. Let's use the first one here. Let's use this one here. First one, 2.44. So let's see if that's correct. This is equal to, so I'm taking 3.94 minus 0.04. What's the y value here? The y value here is 40, as you can see here. So into 40. So this into 40. Let's see what we get. This is equal to 3.94 minus, let's see, 0.04 times 40, that's about 1.6. 1.6. If I subtract this, I'm having 3.94 minus 1.6, and that's about 2.34 in value. Meanwhile, the value here is 2.44. The little difference there is just 0.1, which is due to maybe some experimental error. So that means the equation is actually correct or sensible, right? All right, so let's move on. Let's get back to our questions. All right, so we have this. What's the next question there? The next question there, II says, state any necessary precaution you took to ascertain accuracy of your readings. III says, explain how this setup can be used to determine the value of G. Limitations, if any. All right, let's answer the necessary precautions we took to get the accurate result, and then this one here. All right, so the question solution, we've already answered this. We said for this one we had that c squared, c squared, it's equal to 3.94 minus 0.04 y. Already got this. All right, the precautions we took to ascertain accurate results. We said II, precautions taken to ensure accuracy of your readings. The answer is number one, I ensured that the stopwatch was at 0. Right, I ensured that the stopwatch was at 0 before measuring the time of oscillation to avoid zero error. Number two, I ensured I was alert and stopped the stopwatch at the exact time, that's after 20 oscillations, to avoid personal error, example reaction time. Now reaction time is what happens when you don't stop it at 20. So it goes, the pendulum bomb swings, let's say 17, 18, 19, 20. Before you stop the stopwatch, it's already 21. That's an error due to reaction time. So I said I made sure I avoided it. When we say zero error, the number one here, when we say zero error occurs when your stopwatch is not at 0, and then you start taking reading. So let's say if the stopwatch is at 0, okay, let me try to illustrate this. Let's say I have a stopwatch here, okay, and then this. So this is my 0 point, and then I start the stopwatch. If it's at 0 now and I start the stopwatch, let's say, okay, let me make this bigger. Let's say I have a stopwatch, something of this nature here. Let me make it big, okay, and then I have this. So let's say I have here as 0, and the pointer of my stopwatch, I'm just assuming this now, is at 0. Now the thing is this, if I start the stopwatch, if I press this down and start the stopwatch, this man reads up to, the time reads up to 20 oscillations. In a case where the stopwatch is not exactly at 0, let's say before I started, the stopwatch was not pointing at 0 or was not at 0, and let's say it was instead at, let's say, 0.1 or 0.2. Now what you observe is that by the time I calculate my 20 oscillations, it will be the value plus that 0.1 or that 0.2. That means an extra time will be added in the normal 20 oscillation time, and that will be an error due to your instrument error. And this one is called zero error because the instrument was not at 0 when you started. So I said I avoided that. Number three, I said I ensured I carefully counted the number of oscillations to avoid erratic error. Some persons, they don't count their oscillations. They just go 1, 2, and they forget. Then they just pick up from somewhere and then assume it's 15, 16, 17, 18, 19, 20. If your count is not proper, you'd have an error. So I'm saying that I carefully counted the number of oscillations from 1, 2, 3, 4 carefully until I got to 17, 18, 19, exactly 20. I stopped the stopwatch. So that's what I'm trying to say here. All right. So they said, how can this setup be used to um, determine the value of G and its limitation? How can it be used to determine the value of G? Now, we know that for a simple pendulum that the value of gravity, G, for a simple pendulum is equal to 4 pi squared um, into y all over t squared. And this is what I should have. This is the equation for gravity for a simple pendulum experiment, y over t squared. But then coming back to my graph, go back to your graph, observe that for the graph here, let me take this one off so to be clear. All right, so observe the slope. Observe that the slope is in t squared all over y. So you can see here, that's changing t squared over y instead of y over t squared. So now we are being asked, how can we use this to get our slope or the value of g? How do we get this? Now we know that the slope um, is in t squared over y, but we need y over t squared. So the question is this: if I have t squared over y, as in this case here, how do I get this value? How do I get y over t squared? What do I do? I will simply have to take the inverse. So I'm saying that my slope, let me write this somewhere. Okay, I am saying that my slope is given in t squared all over y, but I need y over t squared. So what do I do? The simple mathematical idea would be to take the inverse of the slope. So I'm saying that y over t squared is simply equal to 1 all over in bracket t squared over y. Now, since t squared over y is the slope, that means y over t squared is simply 1 all over the slope. That's what it means. So if this is true, that means g will be equal to 4 pi squared. Y over t squared is equal to 1 all over the slope value. And let's see what we get. So from here, we'll have that g is equal to 4, g is equal to 4 pi squared. 1 over slope becomes 1 all over. The value of the slope again, let me go back to this. Value of the slope was this, minus 0.04. Now, the negative is because it's a negative graph. So I'll just ignore the negative. I'll just take the positive value, which is 0.04. So please ignore the negative, just take positive value. That's 0.04. And this is equal to 4 pi squared into, if I take the inverse, inverse becomes 1 all over 0.04, and that's 25. So 1 over 0.04 gives 25. So that means that g is equal to 4 pi squared times 25. If I multiply this, we'll have that g is equal to 4 times pi squared times 25. And this will be equal to 986.96. Now g, the values here, y was in centimeters, it becomes centimeter all over, t squared becomes second squared. So this is how we can actually get the value of g using this setup. So that's it. Okay, finally we ask for limitations. Let's try to get limitations. What limitations do we have here? Number one, the first limitation is that there was air resistance. Okay, so the possible limitation could be number one, air resistance. Okay, so my possible limitation would be number one, possibility of an air resistance, which will cause the pendulum bob to swing slower than usual. So air resistance that could interfere. So another possible limitation would be incorrect time measurement. All right, if the time measurement is not correct, it could be a limitation. So incorrect time measurement could also be a problem or a second limitation. All right. The last thing there would be The last thing here would be a conclusion. So the last thing there will be a conclusion. Let's get the conclusion then. That's all. So how do you conclude this? So in conclusion, to get your conclusion, go back to your aim. If you go back to the aim of the aim of this experiment was to determine the relationship between the time and the length of the path of the simple pendulum. So in conclusion, we can say that um, the relationship the relationship between the periodic time and length is that t squared is equal to, back to that equation, what do you have there? T squared is equal to 3.94 minus 0.04y, um, 3.94 minus 0.04y. So I think this was the aim. So if you get this, we can conclude it this way. And you can also say that this one won't give you, this is not an exact relationship, all right? But it will give you an approximate answer due to personal errors and limitations, which we've already discussed here. All right, so this is how we solve this experiment. If you enjoyed this video, please like the video and leave a comment. Also share the videos so that others can learn too. All right, so your task is simple: like this video, leave a comment, leave a comment. So tell us if you enjoyed this video. If you have questions, please leave the questions in the comment section, and also suggest other experiments that you would want to see. And of course, please share this video to your friends so that they can also learn. And finally, kindly make sure you subscribe to this channel to get more content. Thank you and see you in our next class.